Hello there, this is stream number 17 in the reinvention of the wheel of web servers. So I'm programming my own web server in C++, and there's no one in my channel now, so anyone who's hearing this is watching the video afterwards. So let me give a little background. We've been, over the course of the last 17 streams, been building up some libraries that are going to be used as a core set of basis libraries that we're going to use to develop a web server. And we're getting close to being done with these core libraries, and we'll be able to start an actual web server development, I think, tonight. Because I was looking through what we have left to finish up on the SystemAbstractions library we've been working on lately. And I was originally going to make unit tests for target info and time, but they're so small, and either, in the case of target info, really not code at all, just returning constants. In the case of time, it's just really basic, like one-line functions, or maybe paragraph functions that are just calling one OS function anyway, that it's not really worth writing tests for them. But we do need to fill in some missing documentation and a couple other cleanup things. And let's see, I've noticed one header file that's out of place that we need to move. Excuse me. When you see that overlay, by the way, it means there's some kind of loud noise, and I'm muting the mic for your benefit. So after we do a couple of these finishing up for SystemAbstractions, we're going to start on the actual web server. I don't yet have infrastructure set up to host it live for my viewers, but I'm looking into it. There are a couple different options. I was thinking about either Amazon Web Services or just using my existing dedicated host that I already pay for anyway. And there are a couple other alternatives, right? There's Microsoft Azure, there's Google's Cloud. I haven't really done enough research into it. So in the initial development of the web server, it's all going to be just local on my machine. But I really do want to, at some point in the near future, set it up online so that my viewers can kind of play along, test the server, interact on it, etc. So let's do the finish up first of SystemAbstractions. So, well, first thing I want to get is this target info. I'll show you guys what that is. Target info. Really just two functions, and they're just not, they're missing their documentation. And I'll show you how it's implemented in Windows. It's just really super simple. Get target architecture just tells us if we built the code for x64 or x86, which is 32-bit. And get target variant just tells us if we built the debug or release variants of the code. So I don't think it's worth a test, because essentially they're just constants. But we can fix up the documentation. So let's do that real quick, and then we'll call it for this component, right? This function returns an identifier corresponding to the machine architecture that the currently running program was built for which the currently running program was built. If you haven't seen my streams before, there's a lot of documentation. And it might be a little boring, but it's important, because if you look back at the code like a couple of years from now, you're going to want to at least read an intro for every function to get an idea of what it's supposed to be doing. Another way we document is through unit tests, which we'll see in a bit. So I'm a little repetitive in describing the return value versus the overall function. That's because if we run this documentation through a document generator like Doxygen, it may put the text for the overall function and text for the return value in different areas of the document. So I tend to be a little bit repetitive here. Okay, for variant, this function returns an identifier corresponding to the build variant. I'm just thinking how I would phrase this. The build variant that was selected to build the currently running program. So we'll say that, and we'll call it for this module. All right, and I'm going to update the copyright too. I've been using the C with a circle around it symbol rather than the old style parentheses with the C in the middle. So in a lot of the files I'm going through, I'm going and fixing that up. Another thing I wanted to point out is that, actually, I'm looking at that copyright looked wrong. We'll fix it up to say that. We're only fixing up the Windows build for this library because I don't really have a full setup for both Linux and Mac that I can easily integrate into my stream. When I get that set up, we're going to need to revisit this library to clean up the SystemAbstractions library. And hopefully it won't be that big a deal. We'll mostly be copying our work from the Windows stuff over into Linux and Mac variations. Okay, so we're done with that. Let's move on. Time is the last module we have to hit. So let me update the copyright there in time and the implementation. This needs a little bit more work. It has private properties of the class, and I've been taking this boilerplate. And the difference here, you can see before we just used a undeclared structure. When you do this symbol here, time impl, ends up being scoped to as a global symbol. If you do it this way, where you first declare it and then use it, this symbol is now scoped within the class only, so it doesn't pollute the global namespace. So it's preferred. So that fix up will require us to go into here, and the other thing I'm doing is I'm moving the underscore from the front to the back, because having a symbol start with underscore can be dangerous if the next character is a capital. So technically that's a reserved word in C++. So we're fixing that up. We're changing a few incidental things here. And let's see, yeah, we need to document some of these functions. So this should hopefully go pretty quick. This method returns the amount of time in seconds that has elapsed since the object was created, since this object was created. The time is measured using the performance counter, the high precision performance counter. The system's high precision performance counter, typically implemented in hardware CPU. Okay, then we can simply say that is returned. Okay, in local time, this is really just a wrapper for variations in this function, because they can be different between Windows and Linux. And you'll see, for example, if I look at the Windows implementation, local time uses local time S. On Linux, I think it's local time R. Slight differences. This method is an abstraction of the local time function, which whose name can vary from one operating system to another. It returns the current time using, I think it's a POSIX struct TM format. Let me verify that. I think it's POSIX. To verify that, let me open a new window in Firefox and start typing it in. I think it's in the manual here. I don't really like C++.com though. Let's see if I wanted to see if there's a reference to it. Okay, so it's not POSIX. It's actually in the C99 standard. I thought it originated with POSIX, but I guess I'm wrong. It's in the C library, C standard library. Does that mean that local time is also standard? Okay, yeah. So it's local time SR standard, so to speak. But the problem is their implementations are not consistent between Windows and Linux, right? In Linux, I think they have local time R instead. Yeah, because it's POSIX, thread safe alternative. Yeah. The current time using the standard C standard library format is returned. So difference between local time and GM time, of course, or you might not know, but it's Greenwich Mean Time. The current, I should say here, the current local time. The current time in the in what the system considers to be the local time zone. This is worded kind of funny. Is returned. Yeah, we'll say it this way. Update this, right? It returns the current time what the system considers to be local time zone using the, yeah, that's how we'll say it, I think. And since I updated that, let me take that and copy paste it for GM time. And the difference is according to, I'm gonna misspell this horribly, so let me look it up in the manual. Oh, okay. It's G for Greenwich, but really it's coordinated universal time. According to right. The current time, according to coordinated universal time, is returned. Yes, that's exactly what we want to say. Oh, we need to make a note about the parameter also. Oh, and I'm going to need to adjust. I'm going to need to adjust this again, aren't I? If you pass in a non-zero time, it gives you the local time corresponding to that time. If you pass in 0, it polls the current time. This is the what do we call it? The number of seconds since the, I think it's called the epoch. I'll look it up though. It should be under here as time. The epoch. Yeah, the epoch. As defined by POSIX, and we'll put a little side note in there. I believe it's number of seconds since January 1, 1970. Let's click on it and make sure. Number of seconds that have elapsed since the epoch, since January 1. I thought it would define it here somewhere. I thought it was 1970. Okay. Thought they would. Usually, when you have a link like that, they'd say what the epoch is. I like to have a nice reference. Here we go. Thursday, January 1, 1970. That's exactly what I'm saying. Midnight, January 1, 1970. UTC, right? Midnight UTC. So the number of seconds since this is the number of seconds for which to compute the struct tm format equivalent. If 0, the current time is sampled and converted instead. And for this, we'll just say the given or current time so that you can look at the argument to figure out which. It turns the given or current time. Yeah, that's what we'll say. And we'll fix up the other one too. We have to add this anyway. It's number 6. Oh, we should say that this is local and the other one's UTC. Actually, no. The time value is always UTC. So if you were to pass in, if you were to sample the current time through the time function of the C standard library and pass the same value to both local time and GM time, and subtract them, you should get the. Actually, we can have a test for this. You should get the time zone offset. So local time is good variable. Yes. Turns the given or the given. Okay. It's probably overstating the documentation. It's fine. Okay, another thing I wanted to do is we're defining the destructor, and this destructor, the destructor doesn't do anything. We don't need it. Actually, we do need it. We need it because we're using this unique pointer to an opaque type. Since I do this a lot, I really should find a web page that describes why we have to declare the destructor and implement it privately. But I don't have that reference now, so I'll just you have to take it for granted that that's what you have to do. And I group this into the set of 5 methods that sort of go together, and you can find references to this if you look up rule of 0 or rule of 5. Basically, it says if you implement or declare any one of these methods, you should declare all of them. And that's the destructor, the copy constructor, the destructor, the copy constructor. And by the way, I should probably say no except on all these, just to reinforce that it doesn't throw exceptions. So yeah, once again, destructor, copy constructor, move constructor, and then copy assignment, and then move assignment. And we can start off by just declaring them all to be equals delete, meaning we're saying they're not part of the class. If you call it, it's an error. And then we'll actually define them if they're actually needed. And instead of doing this, a nifty way to do it, modern C++, is just to say equals default. Okay, I think we're good. Technically, for this time t, don't we have to include? Okay, we are including time.h. That's fine. So I think this is good. Let's compile that. I had some warnings there. We should fix. No, it's a fail. So I must have Okay, so we are using the destructor at some point. I want to look at the compiler errors to see where that is. Okay, here we are. Is that using... I'm waiting for the IntelliSense to tell me. I think it's using the move constructor, so let's just define that. We can do the equals default it. But we have to declare and not define it here. That's important for the same reason that we needed the destructor, and it has to do with this opaque type. So what I'll do is copy those two up to the top here. We have to add the scoping, and then just say equals default. That should satisfy... Oh, it didn't. Oh, okay, I know why. It's because I forgot to do put public. Methods are private by default unless you override them. Okay. So, let's check that in, and I think there's only one thing left we'll need to do in this system abstractions, and then we can move on to starting our web server. Should be awesome because we're waiting 17 streams to get to this. All right. So, clean up time and target info modules. So it's update copyrights, fix up simple pattern on time, and what else do we do? Apply rule of 5 on time. That's pretty much it. Oh, added missing documentation right here. And I think we're good. Going back to the notebook, there was one last thing I want to do right. There was a header that is an implementation, an internal header that is in the wrong place. It's in the public API. So I can most easily work on it here in VS Code. Here it is. So this is in our public API folder. We need to move it to our source folder down here. So I'll just drag and drop that. And I need to update our CMake file to reflect that. So it moved from here down to here. It's now source. And we make that change, and then we go to Visual Studio and build. It'll run CMake because it detects a CMake list file changed. And now we have to fix up some of our includes because it's no longer in the public API, it's a private API, which we include like that. And while I'm at it, this should be in alphabetical order. And we'll need to do the same thing here. This one, because we're in a Win32 subdirectory, I have to do // and probably the same thing here, yeah. Like that. So let's see if that fixed it up. Okay, a couple more places. Okay, so from that header, we need to it needs to reach back into the public API. So the public APIs are always accessed through includes like that. And this is another public API it uses. And let's put it in with the other public APIs. And it's probably the last error. I think so. So let's run our unit test suite to make sure nothing's broken. I'll just run ctest. Overall, it runs all of our suites. Okay, everything passes. That's great. So let's check that in, and then we can wrap up this library for now. We'll have to come back to this library to do the Linux and Mac stuff, unfortunately, but it should go a lot faster when we do that because we've already done this for Windows. Okay, so we're going to move network connection impl.http from public API to private source folder. Great, I think we're ready to wrap up that component and start the web server. So I really should have drawn this up before the stream. Maybe I'll just talk through it. So a web server fundamentally is going to be a program that runs somewhere like on the cloud or on a dedicated host. So we'll have to have a program, a host program. But we don't want to couple the fact that we need a program with the other fact that we need to parse requests from web browsers and return responses. That latter I kind of want to put into a library that the host program that we're going to run for the server is going to link. That way we can also embed the core message parsing, routing, and generating of responses in other programs. So we'll at minimum want a host for our web server, which will be a program, and a library, which will be the reusable component that does the parsing, the routing, all that stuff. I'm thinking of just calling that latter HTTP to kind of fit in with our other libraries. So if I were to collapse all this, so we have message headers, we have UTF-8, we have URI. So at least with URI, that's matching the name of the internet standard that defines it, and message headers sort of does, and UTF-8 also does. So what fits in line with that is if we were to make a new directory called HTTP. And so that's what I'm going to do, and I just did it. So we're going to want to make this its own Git repository, so we do Git init. And let's steal the structure from another component we've already made. So include source test, makefile, readme. We'll copy and paste it into HTTP like that, and let's do some fix up. So we'll just do select UTF-8, Control Shift L, type HTTP, and we'll say this is a library which implements, and now I need to go back to my notebook to see what is HTTP. HTTP, at least the first standard is RFC 7230. Although that's really just the first RFC, the syntax. Then there's the semantics of what are the different headers. I think that's 7231, and there's others. But we'll just say that this library implements that which is. So we'll look it up now. Control click to follow it. Hypertext Transfer Protocol, or HTTP1, message route, syntax and routing. Good enough. So our usage is going to be a little bit different because we want to have two classes. We'll have two different paragraphs. One will be server. The HTTP server class is used to, and here's where it differs from the last library. It's used to parse incoming HTTP requests from web browsers or automated programs, parse them, route them to, how do we want to say, programs or plugins, or route them to handlers. I guess we'll use a generic word, handlers. Route them to handlers that can satisfy the requests, and then generate appropriate HTTP responses to return back to the original HTTP request senders. I want to make sure I don't go past 80 characters just because I am old school and don't like to go past 80 characters. There we go. So the other class we're going to want to have is HTTP client, of course. That's used to generate HTTP requests for web servers and parse HTTP responses received back from web servers. Okay, the rest of this is pretty much boilerplate because I am supporting the same platforms, building it the same way, have the same prerequisites, and all of that for all the libraries in this project. So we're pretty much done with that README. Go into the CMake lists, select UTF-8, Control Shift L, type HTTP. So here we want to we're going to have two public headers, at least, server and client. And we'll probably have, I expect to have another public header that has what's in common between server and client. So server and client for implementation, at least. And this is going to be a static library. And this isn't going to be the main web server composite. It's just going to be the core library that deals with the protocol. We're going to be building our main web server out of this and other pieces. So we're going to put it in the libraries folder. Our public API is the same. We're going to have unit tests. Let's define some unit tests. So we'll rename this one server tests, and we'll make a copy, call it copy client tests. CMake, we'll do that little search replace trick here, and change that one to server test, and we'll make another one for client test. And all this is basically the same. And here in our API folder is going to be called HTTP, and we'll have two of these guys, right? That's interesting. You made an UTF-9. It's kind of trying to be smart. So one's server and the other one's client. Same thing for source. Server and client. And let's just make a skeleton client to server class to do nothing at first. Oh. It's not working. Try again. There we go. So this is HTTP serve client, right? Client, and then search replace that word. Actually, I want to be careful here. The namespace is going to be HTTP. The class is going to be server. So server is going to be the word we see most. So what I'll do is I'll search replace that and call server. But then I'll selectively go in here and put HTTP instead. And the body, all this stuff up to the class will drop. And let's write the class description. We can kind of copy that from our README. Like this. We'll just do that. This class is used to parse incoming HTTP requests. And I think I want to include a reference to the RFC while we're here as well. I'll say this is part of the HTTP library, comma, which implements this standard. At least that standard, if not more. All right. And we'll keep the rule of 5 there. We need a default constructor. But the rest of the class down to the private properties will be empty at first. Oh, I called it server when it's really client, didn't I? Okay. Well, let's do a little switcher rule. Call that X, call that server, call that client. Fixed. We just need to fix this one reference here. Server. Oh, right. So actually I'm going to delete this other client one because I'm just going to take this skeleton and make that one client and do a little rename here. Well, first I'm going to do the uppercase one first. Client. I'll do this one next. Client. And we'll, back on our README file, we'll take this text here and replace it here. So this class is used to generate HTTP requests for web servers and parse HTTP responses received back from web servers. Sounds good, right? Okay. Implementation. It's going to be pretty much empty. This one's client, right? So client, I'll fix up the namespace in the 2 places, I think. Or 3 places. There, there, and there. This namespace we don't need yet. We don't need any of this stuff. Fundamentally, we just need its own public API. we need to have an empty private properties we'll be filling later, and I think the only thing we really need is the destructor, which is defaulted, and then empty implementation, right? And I'm gonna just delete that server CPP, take client, rename server, and then search replace server. There we go. Now we'll go back to Visual Studio and build. That'll rerun CMake. Okay, I know what I did wrong. Forgot a few steps. So we set that library all the way up, but I didn't pull it into our main CMake. That's here. So comes before M, right? H comes before M, last time I checked. I think that's all we need to do, because now we change the root CMake, and it'll pull in the subdirectory. Okay, so it regenerated our solution. We should see HTTP shows up as a library, and also under tests, the HTTP test shows up there. We can set that up to in case we need to debug anything. And we have our client tests and server tests. Oh, which I forgot to fix up. Let me do that. So tests, HTTP, that's HTTP test. Okay, there we go. That's client, and fix up the namespace. And minimally, we just need those two. For now, we'll just have a placeholder that does nothing. And let me delete server tests. Duplicate client tests, rename. Fix that up to be that. Oh, that was wrong on the other place too, wasn't it? Yep. Okay. Back to Visual Studio. Everything gets changed up, build. So now we have client tests and server tests both with placeholders, but everything should build, and I can make sure our unit test framework is working. C-test should pick up now HTTP tests, and it does. So we have now 5 suites. And when we want to see detail, we would do HTTP tests, debug, HTTP tests. So we have our client tests and server tests. A couple more things we need to fix up, I think, for version control. So, actually it's just this. So I'm going to use a tool that I made myself to kind of manage a multi-repository setup. All I really need to do first, I need to set this up to be pushed upstream to Bitbucket. So let's get let's check in. We need to make our initial commit anyway. Initial commit. So it's git remote add origin, and then the address. And this is not yet public. Once I do a little bit of research on licenses and stuff like that, I'll probably make it public. Right now, off screen, I'm going to go to my Bitbucket and just create that repository real quick. Just hold on a moment. Just wait a moment. Create a repository. It's going to be private for now, but I promise to make it public as soon as I'm comfortable with having the license and everything set up right. So access level, private repository, create. Okay, so now I should be able to push it. So do git push set upstream origin master. Now in the main directory, I'm going to use my tool to add HTTP. So you see what it did here is it added HTTP with the URL on the branch. It also goes to git ignore and adds it up here. So we should be ready to just go to the main repository and start checking stuff in. So we added HTTP, and added the main, right? And that license I'm still working on. Add HTTP project to solution. Check that in. What's this VS Code settings? I have no idea how that got created. We don't really need that file though. Let's push that. And just do an overall status to make sure there is nothing I haven't pushed upstream. We already just looked at root. And I know there's some unfinished work there. Everything is in sync, I think. Yeah, Google Test it's pinned to a specific version that I know works. This bang means that Google has released updates since I last checked. I don't care because I'm not using their tip. I'm just using something I know works. So we are ready to start making our first test. We're following test-driven development, which means we write the test first, and the test sort of both makes sure that the code does what we want, and it also documents the code, especially if you believe in the code being able to just document itself, right? By reading an example of how something's used, you know how it should be used and what its behavior will be. So, what do we expect an HTTP server to be able to do? Well, I would expect that you could feed it in a request, and even if it's not set up with any resources, it should at least give us a 404 response, right? So we'll start off with an HTTP server, right? And then we're going to expect that it's going to have a method called handle request, right? Or not handle request, because I want the word handle or handler to be the piece of code that actually takes a completely parsed request and figures out what to do with it. The core server itself will not really know how to handle requests. It just parses them and then routes them. So it's more like parse request. That's probably a good one. Parse request. And then we're going to get something back. We'll just call it request. And what it'll do is it'll take in just the raw HTTP message. And I'm going to take advantage of the fact that this standard here has some example HTTP requests that we can kind of borrow. Here's a good one. So here's a request from a client. This is valid HTTP, right? So we should be able to put it straight in there. Of course, I got to turn it into strings and indent it correctly. And also, the spec says it in somewhere, but every line of the request is supposed to have a carriage return line feed combination to mark the end of each line. That'll be one of the things that our HTTP server is going to be expected to check. Okay, so also not shown here is there's a blank line. That's to divide the headers from the body, and there's usually no body in a GET request. So we should expect that we get a request back. I think what I want to do is have the request be a null object if there's some problem in parsing the request. So since that's a valid request, we'll assert that it's false. That request is null. Fair enough, right? Then what are some of the things we expect to be able to do with the request? Well, we kind of want to know what the URI is, right? So assert equal, and we're going to be pulling in some of our other utilities here. URI. Oh, autocomplete is helping me figure out that HTTP needs to rely on URI. So both the tests, well, I guess we'll just start with the tests. The tests are going to rely on URI, right? And I'll build just to trigger CMake. It won't build, but at least it'll be able to autocomplete this now, right? URI. URI. And I have something in here, right? Parse from string. Oh, hold on. That's not the convenience. I had a convenience function in here somewhere, didn't I? Maybe not. I guess we need to set it up first. Should probably add a convenience function. Yeah. Anyway, so we have to set it up outside first. URI, expected URI, right? Expected URI parse from string hello.text, right? So we'll assert that the expected URI matches the request URI. Or request is probably, the request can be a structure, right? So we don't really need to, yeah, so it could just be URI. Of course, none of this is going to compile, because for one thing, your request is, parse request doesn't exist, so it doesn't even know what the type of request is. So let's handle these one at a time. Oh, hold on, we're not really done with our test. We need to name our test first of all. Parse request, I guess. Parse get request. Oh, I skipped the method. That's called the method. So we're going to assert that get is the method. And do we need to worry about the protocol version? I don't know. I don't know yet, so I'm not going to put it in. So what about the header? So we have another class we already wrote to handle that. Let's pull that in. Message headers.
Do you have unlimited resources?
All right, so compile that. And M comes after H, last time I checked. Message headers. I'm just trying to remember, did we make a comparison operator for message headers or not? Okay, we have one for a single header, or header name. We don't have a comparator for header, actually. Yeah, okay, we don't. So I think what I'll do is we'll just assume request has a headers element, and we'll poll it as if it was a message header. So we don't really need this. And I guess means I can remove that, right? So what we'll just do is we'll assume that's a message header, and we'll say, well, what can we do with that? We can ask if it has a header, right? We can assert that true. Request.headers has header user agent, right? And the other two, host and accept language. And not only that, we can check the value. User agent is this guy. Request.headers. And I think it's called get value. I don't quite remember what it was. Get header value. User-agent. And the same thing with host. The host is example, www.example.com. And language is English, and I don't know what MI means. It's a language code though. And the final thing we can check is that the body is empty. So assert true that request.body.empty. What else do we expect to be able to parse out of a request? I think that's about it. Except for we might want to know the version of HTTP. I'm thinking about it. Maybe we'll leave it out for now. So let's start with this, and we will not be able to compile it yet, so we'll at least have to declare this parse request. And we'll have to declare the structure for the request. That's going to go in our public API for server. Oh, I guess I forgot to clean up these headers. Minimally, what do we need? Memory? Nothing else, right? So we're going to need a type called request, and one's going to be returned from parse request. Oh, hold on. I had this mechanism of checking for null, didn't I? So maybe we should just return a shared pointer to 1. That way we can have this null concept of null. That just means that all the request dots become request arrows. And instead of just being a copy of a request, it's a shared pointer to a request. Parse request, and it's just a string, right? Raw request. I know this is going to change, by the way, but we'll keep it simple for now, and we'll evolve it as we go along. So string is declared in the string standard library header. Request we need to give a definition for, but first let's give a documentation for this. This method parses the given string as a raw HTTP request message. If the string parses correctly, the equivalent request is returned. Otherwise, null pointer is returned. Raw request. This is the raw HTTP request message as a single string. The request equivalent to the given raw HTTP request string is returned, and then there's a special return value, which we say retval null pointer. This is returned if the given raw request did not parse correctly. Alright, so what is a request? Let's define that. We'll have a section for types. So a server request is going to be a struct, I think. This represents an overall HTTP server request decomposed into its various elements. And I know I'm going to want to pull in URI and message headers. So just like we did for the tests, we'll need to pull it in for the main module. Oh, I don't have a section for it. It's target linked libraries. And I usually put it after include, so there we go. We don't need JG test, but we need message headers. And we need URI. And that's it for now, I think. So yeah, request, and we'll pull in message headers, because I know I'm going to need that in just a moment. And we'll want URI as well. So the request starts out with, well, let's just write out what the part starts. Method, right? And then URI. And that's called the target, I think. And I shouldn't have called it URI here. It's really target. Is it called target? I'm going to look back here and see what they call it. So it's probably in chapter 3 they start to call it. Still chapter 2. Okay, request line. Okay, they call it the request target. So request target, that's good. And then we have message headers. That's odd. My IntelliSense is failing me. But it is called, it's the namespace and the class is called the same thing. Headers, right? And then we'll have a string body. This, how does the standard call it? The method indicates the request method to be performed in the target resource. I'm just going to copy directly from the spec. This indicates the request method to be performed on the target resource. And what does target mean? Target identifies the target resource upon which to reply to the request. I love it. I don't even have to think about it. I just copy from the spec. Headers. These are the message headers that were included in the request. And I hit 80 characters, so I wrap it. And finally, this is the body of the request, if there was a body, or if there is a body. Okay. So now it will, it should compile but not link. So let's verify that. Okay, so we still have, oh no, it got to the linker. That's exactly what we were expecting. So to get it to link, of course, we'll need to give the definition of the symbol. I'm having trouble with IntelliSense, which tells me I'll probably need to restart Visual Studio. Let me do that real quick. Sometimes Visual Studio's IntelliSense gets confused when stuff changes on the solution and project files because of CMake. This, I should be able to right click and go to definition. Okay, it's working again. And I lost my clipboard for some reason. Copy, paste. Server goes there. And here's one trick. It doesn't know about request because I would have to do that. But I don't really like having to scope both of those. So we can kind of use a newer language feature. We can say auto and then put the return value type there instead, which is kind of nifty. So let's just do the minimum to make it build and see that our unit test fails. You could probably already guess how it's going to fail, right? It fails because we expected the request equals null to be false, but it's actually true. So we're going to have to actually do some parsing. We're going to want to add some tests for invalid or, requests that don't parse correctly. And those, it'll be assert true that the request is null. So what are the things we need to parse? The method, the URI, and for now we'll just verify that it's protocol 1.1 and fail if it's not. Although I think later we'll want to support 1.0 at least, and maybe 2.0. And then what we'll do is we'll leverage message headers, which is able to parse the rest of it down to the body delimiter. So the first three elements are all in one line. So I think what we'll do first is we'll parse the first line out. Then we'll give the rest of the string to message headers, and it'll tell us where the body begins, and then we can get the body. So there'll be three separate steps, right? First, extract what do they call it in the standard? The request line. Second, parse the message headers and identify where the body begins. Finally, extract the body. So I think this should be simple enough that we can keep it in one function. If I'm wrong, we'll refactor these into 2 or 3 different functions. So how do we know where the request line ends? It's not that hard. We just look for the first occurrence of the end line. Every line's supposed to end with that, so if we don't even see one at all, we can immediately bail. So say const auto request line end, and we'll say raw request find that, and I think immediately what I want to do is extract that out, call it CRLF. namespace. We'll make it into an anonymous namespace, and that is a constexpr constchar,
Well, dude just got teleported into Fortnite.
right? This is the character sequence corresponding to
Whoa,
a
that's Viking shit.
carriage return
This is a Viking shit.
CR followed by a line feed LF, which officially delimits each line of an HTTP request. So we can do a check if it's equal to the no position of string end pause. We can immediately bail, right? Otherwise, the request line is the raw request substring from 0 to that request line end. Actually, we're not just extracting the request line, or extract and parse the request line. And I think I do want to move that into its own function, so we'll go ahead and do that right now. We'll say, if not, because we'll return false if it fails, parse request line, return null pointer. And the second part is pretty easy. What we do is, we're going to need one of these request objects anyway. So we'll actually set it up at the beginning. Request. We're not going to change it once we make one. We'll use the make shared, which is construct a default request. And we'll leverage the fact that the request has headers. And we'll just ask the headers to parse the raw message. And it will be the substring from the request line end plus the length. Okay, what I want to do is say crf length. But that's not a C++ string. Let's make it into a C++ string. I'm wondering if I can just declare it and still make it constexpr. Nope. Not at all. So I guess I'll just make it const. Alright. Okay, that can fail. If it fails, it returns bool. So if it's not that, then we'll bail again. It's all early exit out, right? If it doesn't fail, I thought this method actually told us where... Oh. I thought it told us where the body began. Oh, body offset. That's what we want, that overload of it. Body offset. And the line's getting long, so let's break it up. There. And body offset. Okay, so if it succeeds, we'll know where the body is, right? Request body equals raw request dot substring. And since we gave parse raw message of headers a substring of that, we'll have to add that to body offset. So it'll be that plus body offset. And then we simply return the request, right? So we're down to, we just need a parse request line. And I really want that to be private because it's going to update the state. Actually, is it? No. Let's just give it the request. And then it can be a free function. Free function we can put in our anonymous namespace here. So this will be bool parse request line. And it'll take two things. A HTTP server request as both in and out. Actually, no, it's a shared pointer to one. Commit didn't like that. I don't know. Oh, maybe because we don't, possibly because we have not included memory like we should have. Let's include memory. Okay, it's, I think, well, I'm not, probably because I didn't have that line terminated. Let's terminate it. It's wanting this request line, right? Okay, that made it happy. This method extracts the, or parses the, what do we call it? Method, target URI, and protocol identifier from the given request line. So we get the request in. This is the request in which to store the parsed method and target URI. Second input is the request line. I kind of don't like that one is request, that one parameter's name is the base of the other parameter's name. So I have to start thinking about a better name, but anyway, this is the raw request line string to parse. And then we'll have an indicator return. An indication of whether or not the request line was successfully parsed is returned. So should I rename this so that it's not a prefix of this? I could call this raw request line. No, but a request line is raw. So what is this? This is the overall request. I guess it's okay. We'll keep it the way it is. Now the standard talks about request line. It's actually very strict. It has to begin with a method token, followed by a single space, the request target, another single space, the protocol version, and ends with CRLF, right? So we can use space as a delimiter. I'm pretty sure it's safe to seek for that second space because request target is not allowed to have a space in it anywhere. It has to be escaped with a %20, I think, in order to encode a space into the request target. So it's actually not that difficult. What we do is we say const auto method delimiter equals request line dot find space. We'll do some checks, right? If method delimiter is string no position, return false. And then otherwise we can, well, it's really three parts, right? Parse the method, parse the target URI, and then parse the protocol. Parse and verify. Oh, parse the protocol is all we'll say, I think. Parse the request. Hold on, I want to switch back to just check my stream health is good. Okay, good. And I've been going for an hour. And we're looking good. Okay, so parse the target URI. We have a class to do this. Actually, we've already put it into request, didn't we? So it should just be request target parse from string, and we have to give it, oh, we didn't find the delimiter yet. Well, when we do, it'll be request line dot substring from the method delimiter +1 to, it's getting long, so let me break this up. Actually, substring's second argument is a length, so it'll be the difference between the two delimiters. So it's target delimiter minus method delimiter. I think sometimes I get this off by one, so let's look at an example. Oh, better example would be our test, right? So if that position, or where the cursor is basically, is that, and then that's the second delimiter. If we subtract them, we'll get that length. So I want to, oh, I already added one. So from there to there. So yeah, we can just subtract the two. Subtract the 2, right? And then it also returns a boolean, so we can simply say if that fails, then return null pointer or return false. And it my indentation style might look a little weird. I kind of gotten into a habit of doing it this way, so sorry if it looks a little weird to you. Oh, except for that. I try to keep lines from getting too long, and this is better on my eyes. It might not be good for everybody though. Sorry if it doesn't look good for you if you happen to be watching. Okay, so we still need to find the target delimiter. And we also need to store the method, by the way. Do that in a second. Target delimiter is a request line is find, and then we'll use the overload that lets us give an offset. So we'll start searching for it at the method delimiter +1. And we need to store the method. So that is request method equals request line substring from 0 to the method delimiter. Right? Target delimiter is that. I just stopped, had a thought. If there's 2 spaces in here, I think our URI parser, this guy, might be a little bit lenient and allow it. We should probably have a test case for that. I'm not sure if that's technically legal or illegal though. It does say single space, so it does sound like it's probably strict. Anyway, the target delimiter, the protocol always comes after the target delimiter. So const auto protocol equals request line dot substring. The request line already has the character turn line feed stripped off, so we'll basically go from the target delimiter +1 to the end of the string, right? And I think all we'll do for now is we'll just do a check. If protocol equals exactly this string, then we'll return true. Actually, and we can turn that into a tail call. We can just say return that the protocol's that, right? So I think that's it. We can run our test and see if we succeeded. I hardly ever succeed on the first try, so we'll see. We succeeded on the first try, yes? No, we didn't. We failed. So let's see what went wrong. Let's single step through it and see what happened. Okay, so single step in. The request line in, so it found it. The request line looks good. Parse request line failed. So let's restart and debug to that second breakpoint and step in. So parse method. The request method's get target delimiter. Okay, it found it. Okay, so it didn't parse the target correctly. So again, let's restart. And we'll go into that. Okay, so the URI string is /hello. Parse the scheme. It doesn't have a scheme. Split authority. Okay, so parse path. Parse path failed. It looks like a valid path to me. We might actually have a bug in URI. Because that looks like a valid path string to me. It has a space at the end. Shouldn't really have a space on the end, but also it shouldn't... Oh, maybe that is the bug. Let's see. What does parse path have to say? Clear if path string is /. Else we find the / we found it. So path has an empty string in front which marks an absolute path. And then we strip off the slash. And it pushes path. It pushes the rest of the path on and clears that. Oh, I see. It's decoding, and a space is not allowed. So yeah, it really doesn't. It doesn't like that there's a space there at the end of the string. How did that space get there? Did I miscount? I probably miscounted. Oh, it was in request line. Yeah, so I was just confused there. Method. Yeah, I remember stopping on this and just trying to make sure that I understood it right, but I guess we didn't count it correctly. Oh. Method delimiter is the left side of the space, and I was thinking it was the right space, so it's +1. No, -1. Off by 1 bug. So I think that might have fixed it. So let's run our tests. Yep, so we were passing. So we were able to parse a request. As neat as that, huh? Most of the work is actually being done by our message headers, which we wrote, I don't know. What does my notebook say? Message headers. So back in stream 10, if you're interested, if you're watching, you can see how we parsed headers. The request line we just did, and once you see the message headers in the blank line, you know the rest is the body. So it's pretty straightforward. So let's do one which has a body. I don't know if that would be like a post, right? I don't know if there's an example in the spec, but maybe we'll see if there is one. No, there isn't. We can invent one, I suppose. It's better to find one for real though. So HTTP post example might be. It's probably some out there, right? Wikipedia probably has one. Really? They don't have an example message? Huh. MDN, it probably has one. Okay, here we go. We will shamelessly grab that off of MDN and paste it here and essentially copy our test, but say parse post request and put it in here. So we get just a little variation to our testing. I wanted a post example because it has a body. I want an example that has a body. Okay, so we expect that the path is slash. The method is post. It has a host. Host is foo.com. Instead of useragent, it's got content type, so we'll hijack that and repurpose it. And then it has a content length of 13. And then we will assert that the request is exactly this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that doesn't really have a character return. 9 feet at the end. And I already know what we're going to do next to our parser. Because the hint is the content length, and what if you had stuff after, right? So, but this should pass right away, and it'll give us a little bit of a base to do the next feature. We can actually check this in if it's working. Okay, let's check that in. So we can say in HTTP we got basic server requests parsing correctly. Right? HTTP server handle or accomplish basic server request HTTP server request parsing. Right? So the problem is, what if you did have like more junk after that? This should still pass, right? But it's not. It's going to fail. The body ends up with that extra set. The trick is that the parser's got to be a little bit careful. If there is a content length, it has to, after when it sees the body, it's got to limit what it puts in the body to just those characters. And we probably also want parse request to tell us where the point at which it stopped parsing, like message end. So let's do that. Let's say message end, and let's say we want to be told what that message end is, and we'll say that the message end is whatever the length of this request. Let's pull that request out actually. Const standard string raw request. Let's do that. Put the raw request in here. I can refold that line again. So we can say that we expect message end. Oh, sorry, raw request. Oh, hi Snorpy, how's it going? Am I a developer full time? You have some questions about moving to a C++ role? I don't mind if you ask me. I am a developer full time. I've been working 20 some years. So go ahead and shoot your questions. That's fine. So let's see, message raw request dot, yeah, dot length is probably a good one. And it's just these two characters we expect. We expect that to be the message end, right? Okay, so it doesn't like that we added a second argument. Let's add it in a way that doesn't disrupt our other test. One way to do that would be to add an overload. So in server.hpp, we'll add an overload. Overload is basically you repeat the same thing, but you add another argument. It's one of those cool things that we can do in C++, right? As long as we don't abuse it. We'll basically copy the documentation from before, but we'll add another method. Add another parameter, which is an out. This is where to store a count of the number of characters that actually made up the message or the request message. Presumably, any characters past this point belong to another message or are outside the scope of HTTP, right? We'll leave it up to the user to figure it out. In some contexts, it'll be the next message. In others, it'll just be junk. So now it should compile but not link. To make it link, we got to give a definition, right? Just notice I have a bunch of breakpoints I don't need anymore, so I'm going to clear them all. So it goes down here at the bottom. Although, technically what I'm going to do is put it there. Do the same trick with auto that we did before, where we put the return type on the end. And basically I'm gonna move the code we had before into here, and message end will set somewhere. And we'll make the old function call the new function with just throwing away that message end. Return parse request raw request that message end, right? And this is very cheap because it's what's called a tail call. The compiler will probably turn that into a jump directly into this function. Alright, I thought I heard something. All right, never mind. So to make this test pass, we got to be smart about content length, right? So instead of just assuming that it goes to the end of the string, we're going to check for content length header. If present, use this to how do I say this? The right way to say this, let's see. Let's think. Use this to determine how many characters should be in the body. Okay, I got your chat. I'm just reading it. Your developer as well, big data and finance industry. You wanted to move to a quant or HFT algos role. Recent grad. Not as developed as others have lots of interns. Just wondering when there is knowledge you expect someone to have to separate from intermediate to advanced dev. I mean, there's quite a large spectrum of things in C++ capabilities. Some companies are going to look for systems level, like low level C++, C. Others are going to want to know about more like algorithmic use of the language. Some will be very specific on certain libraries that are in C++ that they'll want you to be able to at least read. So my general advice would be you should know all of the core parts of modern C++. So like if you look up Steve Meyer's Modern C++, that's a great book to browse through. If you understand all the basic concepts that he talks about, then you'll be in really good shape. Let me think a little bit more about your question, though. I mean, someone who's looking for advanced developer, it depends. If we're talking about the really new versions of C++, like C++ 17 and C++ 20, an advanced developer would probably be in touch with all the latest things they've added to the language. A lot of the stuff like template metaprogramming. I'm not even really that versed in that stuff. But it's gotten pretty crazy. If you look up C++ 17 and C++ 20 and template metaprogramming, or if you just look at like one of these headers, like memory, and you start to see what they do with templates, like all this stuff, it can be pretty intense. Like to the point I can't read this at all. Can't read it. I could probably, if I slowed down and studied it, I could probably pick out bits and pieces, but stuff like I have no idea what is assignable is. It's some kind of template metaprogramming, right? So an advanced developer might be expected to know like the latest stuff and be able to read the standard library implementations and figure it out. But someone who's more looking for real world coding probably wouldn't be expected to know this stuff. Like I've never needed to know this stuff working 20 years in C and C++. If someone's asking you to just write apps in C++, you don't need to know any of that stuff. So I hope that answers your question a little bit. I hope I hit the mark. Let me know if I understood your question and answered it well enough. Let's see. Yeah, so we need to check for this content length header. If it's not there, we'll just default to this old behavior, but if it is there, we need to make sure that we have that many characters. If not, it's going to bail. If we do, and they're extra, we ignore the extra, right? So let's just say if request headers has header content length. Then we go into this. So we'll need to parse that. Here's where I kind of need a handy parser for strings to numbers. Did I make one of those already? I kind of feel like I did. Where would I have done that? URI maybe? Yeah, where we parsed port numbers, right? So I probably have a helper function that does that. Yeah, here we go. Parse UN16. let's pull this out. I think at some point when I do some refactoring, I want to make a more generic version of this. You could use something like shifting to or shifting out of a string stream, or using scanf. But hey, I'm into reinventing the wheel, right? So let's just do do some real wheel reinvention. So how are we going to modify this? We want to support preferably large numbers. So let's just make it parse a size, and we'll just use size t, which by the way is defined in standard def. And yeah, let's see if this matches up. This function parses is giving a string as a size integer, detecting invalid characters, overflow, etc. Right. So number to parse, where to store the number. Okay, everything else is pretty much valid. The type is now this. I'm just stopping to pause to think, how would we detect overflow? Because we did it before by using internally a variable that could fit more bits than what we needed. Maybe what I'll do is I'll just cut it off at a certain ridiculously high value. Or maybe I'll make it, maybe we'll remember what it was in the previous loop, and if it overflows, the value should be less, right? Actually, not necessarily. Oh, if we take the new number and divide by 10. Yeah, I have an idea how to do this. So we'll just call it num. No, we don't even need that anymore. No, actually we do. We'll call it previous number. So we'll say previous number. Oh, we don't need to store it between loops either. What we can just do is we can say previous. We don't even need to say the type. Say previous number equals number. Then we'll take the number and multiply by 10 and add. And here's the overflow check. So we're going to rewrite the overflow check. What I was thinking is we can just take the number and divide it by 10, and it better be equal to the previous number, right? If it's not, then we definitely overflowed. If we do overflow and we divide by 10, it's going to be smaller than the previous number, right? I think this is good, but I need to think about it. Is it possible to multiply by 10 and add a number from 0 to 9 and actually get, and then divide by 10 and actually get the original answer? Me not being very good with math tonight. Okay, just seeing your chat. Yeah, it does. I'll look into the Scott Myers book. I think I'm pretty good right now. Of course, okay. STL, pointers, references, templates, OOP. Get caught up in topics like multi-threading, concurrency, networking. Well, those, I consider multi-threading, concurrency, and networking is separate from C++. C++ is like the language, and multi-threading, concurrency, and networking are more like a philosophy that is spoken using a language. So you could study multi-threading in Python or Java, and it would be the same concepts as if it was C++. And a lot of things like networking isn't even in the C++ yet. The whole point of the last stream I was doing, my SystemAbstractions library, one of the things that it does is it abstracts the concept of network connections, because those are different between different OSs, right? WinSock, for example, is close to, but not exactly equal to BSD sockets. So networking isn't even in C++. Multi-threading and concurrency, you could say that they added it, but very recently. That said, probably if someone's interviewing you or if you're looking for a position somewhere, they're not just looking for do you know C++, but yeah, they might want you to be good at those concepts as well. And I don't know. I would think that if you had a good grasp of the concept in any language, then that's probably good enough. Mapping a concept to the language is a lot easier than understanding the concept in the first place, right? In the last part of your message, but within the context of a large program, you don't find yourself understanding where in programs it would be applicable. Okay, I think I understand. What you really need to do, I think, is study a large program that handles multi-threading, concurrency, and networking. And I think just reading someone else's code that does that, as long as it's well written, you'll start to get the idea of what you have to do. And not to say that my code is any good, but I do have to handle concurrency. For example, in network, it's this network stuff again, right? So in my network endpoint class, I use mutex. And I use a condition variable, right? Oh, maybe not here. But the fact that I have a lock there, and that I have to release the lock before I wait. I mean, that's an important concept to know in general, regardless of the language. You know what happens if you don't release a mutex and you start waiting? You could have a deadlock because someone else tried to get the lock. They have to wait for you now to wait almost, perhaps an infinite amount of time while you're waiting for something to happen and holding the lock. So that's actually like a good interview question I would ask someone just to see if they understand multi-threading concurrency. I would say, well, I would do that and like chop off the rest of this code, right? Like that. And say, well, what's wrong with this block of code here? And I would expect for them to study it for a while and then say, hey, you're waiting, but you're still holding on to this lock, right? That's the problem. And I expect for them to say, well, you need to release that lock while you're doing that wait. Stuff like that. So if you study anyone's code at all and they do any kind of waiting with locks, you'll start to see that, and you might be wondering why they're doing it in the first place, but I think it'll come to you if you look at enough code. Or if you just try to implement something that has multiple threads. And you'll run into problems, and while looking up solutions, you'll discover why things have to be done certain ways. That's what I've done for. Experience is built off of your failures, and then realizing why you have to do things a certain way to fix them. Hope that's not too long of a rant. So let me get back to this problem. I'm going to guess that this math is good enough to detect overflow, and then I can just simply return true. If that never happens, we don't overflow. And I'm going to ask my mathematician brother later if this is a valid way to detect overflow. Okay, see you, Snorpy. Talk to you soon. Okay. Yeah, so I'm using that parse size down here for content length. So parse size, right? If it fails, we're going to bail. And we're going to put it somewhere, right? Content length. Parse request headers.get header value content length, and put it in content length. If it fails, we bail. If it doesn't fail, now we have to check. We should probably pre-compute what we think the size of the body is, right? Let's do that. So, in fact, I'm going to move. No, I'm going to say max content length is the raw request length minus, and then I'm going to pre-compute body beginning as well. So const size or auto body offset. No, we already have body offset. So I can simply add that to body offset to fix it up, because it was computed relative to that. So body offset plus equals that. And since that's in two places, let's fix that up as well. const auto headers offset, right? And that's this. Now we can put it in both places. And that cleans up a little bit, I think. So I think that is the max content length. Oh, hi, Rally Monkey. Should I forward the question a moment ago to? Oh yeah, sure. Did you see the question? It was up here. So size t, of course, is not an infinite number of bits, but it can hold a number from 0 to 2 to the power of some number, usually 30, what is it, 31 or 63. So if you multiply that by 10, and then add a number from 0 to 9, either of these two steps, it could have overflowed, right? So I want to see if you divide it by 10 and compare it to what it was before you multiplied it by 10 in the first place, is it always true that they're equal if it didn't overflow, and they're not equal if it did overflow? That's the question for the math whiz, right? I think so, but I'm not sure. Not absolutely sure. Because if I can't do that, then I have to think of a more elaborate way to detect overflow. Okay, so we're going to pre-compute, I can use auto here, that the max content length, I think we can also const that. The maximum that it could be and still pass our parsing is the total length of the request minus where the body starts, right? So then if it has a content length, we need to check if content length is greater than the max content length, then we don't have the whole body and we'll just bail, right? Else, here we'll do the request body equals substring again. Oh, and didn't I pre-compute that somewhere? It's up there, right? Headers offset plus body offset. So it's just body offset now. Body offset, and then the length is going to be content length. It's exactly. And then we're going to return message end. Message end being body offset plus content length. I need to combine these two. I really need to make that to be an else, but I want to separate extracting the body from that. So I think this comment really goes here. If there is a content length header, we carefully carve exactly that number of characters out and bail if we don't have enough. Otherwise, we just assume the body extends to the end of the raw message. Okay. And then we need to set message end, right? So message end is simply the raw request.length. And then we return the request at the end. Let's test that. That should make our test pass. It didn't. So I have a bug somewhere. I love bugs. I love bugs so much. 49. Okay, it failed. Well, let's see why. Step into that. Oh, I went out too far. Retry. Okay, so make the request. Request line parsed correctly. Headers offset 17. We get the headers out. Let's look at the headers. Okay, host, content type, content length. Max content length 15. It has a header content length. Okay, the parse size didn't work, so let's see what happened there. Okay. Oh, get header value. Okay. Number string is 13. Oh, look, I forgot to initialize it. That's a common mistake. And that's why the debugger is very useful. It was quicker for me to run through the debugger and see that than it would have been to figure that out by looking at the code. That's kind of like the cutoff I make. If I have a feeling that either the debugger would find it faster than I would, or if I'm tired and I don't want to use my brain to imagine the code running and to see the bug, I'll just run the debugger. It's sort of a safety net. Okay, that's weird. There's something weird going on with my Streamlabs schedule. It keeps flipping between now live and time of next stream. Is the quality of the stream good? Actually, I'm gonna do a latency check. One thing I do latency check is flip to my notebook, and then on my preview see when it actually flipped. Okay, it's actually not that good. It's like 5-6 seconds. 6 seconds, yeah. I have it on low latency mode, but maybe it's my internet connection is slow. Anyway, it failed because of that. So I built it. Let's see if it passes now. Oh, it did pass. It passed, and my brain got derailed. So we're passing now. So we're obeying the content length. Let's make a test while we're at it. For when the message is incomplete. I have too many windows up. Well, let's close them all. And go to HT server tests, right? Clear all my breakpoints. How long have I been streaming? It's OBS says an hour 47. Okay. So this is a post request. Now let's make a special test for parse incomplete message. Parse incomplete message. So there are two ways. There are various ways we could be incomplete. So we'll say it's incomplete body, and we'll have an incomplete headers as well. So incomplete body would be something like we set the content length to 100. It should not parse. I think later what I'll do when I'll add diagnostics, I'll also check to make sure that it failed because of the body being truncated, right? We should get a diagnostic message back saying that. But I don't have diagnostic messages in yet, so I will not check for them. So another way it could be incomplete is it can be incomplete in the headers. And there we can cut it off at any arbitrary point. Let's do that one. Incomplete headers between lines. And let's do one where it's incomplete headers mid-line. And I'll just cut it there, some arbitrary point. And let's keep making it more and more aggressive. So parse incomplete request line. That's maybe a corner case, right? Now how about another one where it's no headers? No headers request. So it's like that. All of that should fail. Let's make sure. Okay, 120 succeeded. That should fail because there's no body to parse. That might be a bug in message headers, actually. Message headers should expect at least a blank line. Let's see what happened. Okay, the request line should parse correctly. Okay, and then we get into the headers. This is the one that should fail. If not, then we have found a bug in message headers. So the raw message is basically an empty string. Oh yeah, okay, so it's a problem. If we break out of here and we have not seen a blank line, this is where we see a blank line, right? If we don't see that blank line, then it's bad. Oh, okay, so the proper procedure for this is to go to the source of the bug and make a new test to catch it. So let's do that. Message headers test is what we're looking for. I'm surprised we didn't catch that before. Add header, set header. So it was back when we were parsing, right? Let me collapse all this so I can look at all the names of the headers. Okay, the header line too long. Here's some negative cases, so we'll add it near here. Header line or so really it's a missing body. Or truncated before body. So we don't need this test header name anymore, or any of this. Here's the test case. It should not parse. Kind of like this, right? So it's when we do that, it should not parse. And let's see, that was in message headers test debug message headers test. It's passing. That shouldn't have passed. Oh, is it because it didn't go into the loop at all? So if I do something like this, comment this out. Okay, yeah, so if it even has one line, it detects it. Okay, so it's a special case. It's empty message, right? Empty message. I'm actually curious to know why it succeeded. It shouldn't have succeeded when, I mean, you know, why the test succeeded. It shouldn't have. I'm really curious to see why. Let's see. Oh, run the correct tests, please. Computer. There we go. This should have failed. All right, so it has separate, blah, blah, blah. Oh, that's interesting. Advance and unfold expects another line. Oh yeah, it should expect another line. It could be a blank line, though. What does it do for the last line? Next line ends. Oh, okay, I see. If the next line is blank, it's not a line to be unfolded, and so it returns true. But if there's no line at all, it doesn't find the next line terminator and returns false. So okay, yeah, this is a special bug case. Not just, yeah. So yeah, exactly. We can even fold that down together. There we go. So even having one line will cause it to fail, but having a blank line doesn't cause it to fail like it should. So we'll add a special case for that. What was it again? Parse raw message. There we go. Okay, yeah, I can see it's also going to fail if we have a message, but it doesn't have like it's cut off right away. If we just had something like this, it's also going to fail, I think. Empty message or truncated message. Truncated, single truncated line. I think both of those tests are going to fail. Yep. So we have to handle both of those cases. So one is where it'll go into the loop, but then break out right away. The other one is it never goes into the loop at all. So I think what I'll do is I'll detect if offset is still 0 after this line. If offset is 0, then return false. That means we didn't get a single line. That should be enough. Okay, that's enough. So let's check that in as a bug fix. So there's an example of how you deal with the bug. You make the test first that as close as you can isolates the bug. So you're just testing to that you can recreate the bug by seeing a test that should pass and it instead fails, and then you go do the minimum that you need to do to make those tests pass. Hopefully that's one and the same as fixing the bug. Fix bug in parsing, what do you call it, incomplete messages. Empty string and a single truncated line were not being detected as bad messages. If there is at least one line, it gets detected as a bad message. Because of the lack of a next line when looking ahead to see if line unfolding needs to be done. Unfortunately, if there isn't even one complete line, there was no unfolding check at all. Solve this problem by checking at the end to see that at least one line was parsed from the raw message. You have to have at least one line, right? Oh, what if you have a line with absolutely no headers? Okay, I'm not going to check that in yet because I just thought of another test case. What if you had just a single empty line? That should actually succeed and have no headers in it, right? So so no headers at all. No headers at all. It should succeed, and it should be true that the headers.getAll is completely empty. Empty. Let's make sure that that works. I have a suspicion it's going to fail. No, it worked. Let me see how that works, just because I'm curious. Okay. It goes in one, it finds the line terminator. It's going to stop right away. Oh, I miswrote the... Oh no, okay, that does succeed. Because the offset isn't 0. Okay, so yeah. Offset isn't 0 because it actually advances past it to find the beginning of the body. Yeah, good. Alright, so we're good. I'm going to keep the test though. Just reinforces that it should pass parsing and have no headers. So we'll include that. Yeah, okay, good. Found a bug. I'm happy about that. Back to HTTP. Let's see if our HTTP tests pass now that we fixed the message headers problem. They do. Awesome. So That's exactly what I was hoping for. Back to developing HTTP. The test that was failing now succeeds.
He's right there.
Okay.
My God.
What are you guys playing? Oh, they're playing. My son's playing Fortnite behind me. Kind of funny. All right. Let's see. Parse no headers. Oh yeah, these are all invalid, right? Did I? Yeah, what are we as far as check-in status? We modified that. So what did we do? All right. So yeah, we basically added handling of content length and used it to check for incomplete messages. Server handle content length and detect incomplete messages. All right, so what's next? What is next indeed? Hold on, I'm just checking the stream health. It says excellent. I hope it looks excellent. Okay, so let's look at the spec to see where's my window on the spec. Back to the spec. We might actually be done already, believe it or not, with basic requests. We're going to want to handle more advanced kinds of requests too at some point. I guess we could move on to HTTP client and handle status lines in response messages. Could do that next. Yeah, this is what we'll have to handle at some point, is transfer encoding, chunked transfer encoding, because it's like the content length variety, but instead of specifying the length, you have the message in pieces, and you basically keep parsing until you detect a complete message. Right? It goes along with this stuff. Determining the length of a message body is if there's a content length is this one. Right, so we're handling case 5. And we're handling case 7, right? No, the message length is not declared, so the body length is determined by the number of octets or bytes received prior to the server. Yeah, so we're handling 5 and 7. Are we handling 6? Request messages and none of the above are true. I guess let's see if 1 through 4 are being handled. So we should probably handle these. Because explicitly, if the method is head, oh, it's talking about responses. So this is a client concern. So again, this is a response one. So this 3 is about chunked encoding. What's 4? Messengers will receive without transfer encoding, with either multiple lengths differing or a single one having an invalid value. We're already handling that. We're detecting an invalid content length. But we're not doing the multiple. Actually, we kind of are, because when you call get header value and it has multiple values, it's going to comma separate them, and then it's going to fail to parse as a number. So we're kind of like, as a side effect of that, handling 4, I believe. So we're handling 4 and 5 and 7 and 6 is if none of the above is true. Oh, okay, so let's see. So it doesn't have a content length, it doesn't have a transfer encoding, and it's not a response. I'm not understanding why they put, this is like none of the above, but why did they put that as 6 and not 7? I need to read this more carefully. So 1 and 2 are responses. 3 is transfer encoding is present and it's chunked encoding. Four is it's received without transfer encoding and with either okay, so that's a bad message. 5 is it's valid transfer length, no transfer encoding. Content length, no transfer encoding. Okay, I guess it's if it's a response. Oh, I see. Yeah, so 7 it's if it's a response. So that'll be in the client class. Yeah, and this strikes a bell in my memory. I think this is for handling if a client just sends some text and immediately just closes the socket right at the end, the server is just supposed to say, okay, the body ends wherever they closed it. So are we handling 6 or not? Are we? So we need to fix that. So an example of that would be we don't have a content length and it's not chunk encoded. It needs to have no body. So if we give it a body, and we shouldn't have, so like it'd be an invalid request. So it'd be kind of like this get request, but if we accidentally added a body at the end, so something like this. And then if we asked it for a body, well, yeah, body. It should have no body. So the same kind of thing. We don't really need to repeat this junk here, though. Yeah, so there's no content length. This should still be true, and I think this is going to fail. So this is explicitly case 6. Request with no content length or chunked encoding, right? Chunked transfer encoding has no body. That's going to fail now. We need to make sure that passes. Let's watch it fail. And there it did. So to handle that, we need to be careful. If it doesn't have a body length, then we only do this if... Actually, we don't do that at all. This is just incorrect behavior. Really, the body is empty, and the message ends at the body offset. Right? Because we don't handle chunked transfer encoding yet. We'll handle that as like another else if, I think. Body is empty. Clear. Right? That should fix that problem. And it did. So we'll check that in. This is server. Request, fix assumption about body. Okay. This corresponds to condition 6 in RFC 7230 section. I like to quote the spec if I can. 3.3.3. If a request has no content length header, and is not chunked is not sent with chunked transfer encoding, then the message body length is 0. The message body length should be 0. So even if 1 is given, you can't assume that that's the body. In order for that to be the body, it has to either be chunk encoded or you have to be have a content length. That's the rules. Them's the rules. All right. Let's push that upstream. I haven't pushed this upstream in a while. So we're handling 7, 6, 5, sort of. Right? Yeah, but this is where you have a content length, but it ended too early. Right, we haven't received the whole message. It's not valid. So we're handling 7, 6, 5. We're handling 4. And 1 and 2 is for the... No, okay. So 1, 2, and 7 were for responses. So the server-specific ones are 3, 4, 5, and 6. And we're handling all but 3. 3, we need to handle transfer encoding with chunked, specifically. That is going to probably take a whole stream in and of itself. So let me leave a note here in live 17. To do handle chunked transfer encoding. To do server. That's going to be a subject of its own right. But other than that, we're handling the message body length correctly. What else do we need to do? Okay, this is just rules about what we should do if the message fails because it's too small and all that stuff. Message parsing robustness. Yeah, we need to decide what to do about older protocols. That's probably the subject of another stream. I need to research that too. To do server research how to properly handle protocol versions other than HTTP 1.1. I'll basically need to study this RFC and kind of collect notes and that kind of thing, like doing research. It's a little bit, I mean, it's necessary for coding because you have to understand what you're implementing, but it's sort of not coding, right? So I didn't want to do reading and researching on stream. I'll do that off stream. Yeah, chunked coding. Do we have to support all these? So we need to do compress, deflate, gzip. Are they required? Okay, here's all the detail about how we have to do chunked encoding. Compress. I'm wondering if it's required to be supported. I think it is. I'm looking to say where it must be supported. Let's look for the word gzip. So your recipient must be able to parse chunked encoding, but what about zip? Maybe it's optional. If it's optional, I'll leave it for later. That's the registrations for it. Oh, hey there, JD. How's it going? I'm just looking through the HTTP standard right now to see if gzip transfer encoding is something that we must implement or if it's just optional. Blah, blah, blah. I'm sure it says it here somewhere. We can respond with 501 not implemented. I don't see it immediately, so let's cheat and just do a Google search. HTTP is gzip required.
Well, look at this.
Okay. Nowhere do I see that servers are required to implement it. In fact, you have to. Looks like you have to opt in by saying you can accept it or not. I'm gonna say it's optional, and we'll just leave it for another stream to implement it. Yep, implementing an HTTP exactly. HTTP in C++, and it took me 17 streams to get to that point. I'm happy I'm finally actually doing it. So, yeah, back to my notebook. I want to write down that to-do server handle the optional encodings, which is gzip. What were the other ones? Back over here. Gzip compress deflate. I want to support them, but they are optional, so I can kind of postpone them if I want to. Am I new to C++? I guess it's a subjective thing. A master at C++ might call me a noob, but I've been doing C++ for about 20 years. You're looking into doing some D-lang. Are you talking about D, the programming language? I have a friend who's into that. It's like C++ the way it should have been designed and written, right? Okay. I think we're done with basic message parsing, except for chunked transfer encoding, which I'm saving for later. Compress, all gzip, transfer encoding, trailer. Yeah. Yeah, I think we're done with server, so maybe we'll jump to client. Yeah, so 20 years is good and bad, right? So when I first started doing C++, there was no C++ 11. So I've had to unlearn a lot of old C++ habits. And that's probably why I'm still on C++ 11. If I was learning it now, I'd probably jump straight to C++ 17. But I still struggle with the newer things that they've added to the language. C++ 11 I just picked up in the last couple of years. Okay, so we're gonna make sure this is all checked in, and we'll put some meat into the client side of things. Okay, let's go over to the clients. The client's empty right now. It's just got a placeholder, so let's fill it in. Well, it's gonna be a lot like the server, only kind of flipped around. So we'll do that. We'll copy from the server test and we'll call it client test instead. Client. Client is all about parsing responses instead of requests. So the client is going to parse a response. And I'm going to pull from the spec again. It had that nifty example in there, right? We'll just copy from that again. Here it goes. So you've been trying to learn C++ to just get sucked back into coding in JavaScript? I'm the exact opposite. I've been trying to learn JavaScript and I keep getting sucked back into C++. When I get my web server up and running, the first thing I want to do with it actually start making web apps for it in React. I probably have that in a note down below somewhere, but I keep getting sucked back into C++ because I do that for my job. Really want to get into JavaScript. It's really hard at my work to find an excuse to learn it. Okay, so parse response. Oh yeah, so we're going to put the response here. We're going to want to kind of format it the same way. And every line has character turn 9 feet at the end, like good little lines should. And then we have to escape a few of these internal quotes. Hey, you're learning React? Awesome. There's a guy I follow, Adam13531, who is making a game completely in React. And he's on Twitch, and I'm following him. Definitely recommend following him. He's on vacation right now, though, so you'll have to check back in a couple weeks. But he knows it so well, he just flies through it, and I have a hard time following him. It is awesome, isn't it? I especially like that when you do create React app, right off the ground, they give you like a not just a static page, but it's got like a rotating CVG. What is it? Yeah, scaled vector graphic, and yeah, it's slick. See, so request. Okay, turning this around. Response. We do not have a URI in it. It's just protocol status and in 2 pieces. So we're not parsing URIs anymore, but we do expect to get 2 things. I expect OK to be the, what do they call it? I want to use the same names as spec does, so status line, I think. Status line has reason phrase, and then we expect 200 for the, I think they call it the reason status code. You must need blazing fast web apps with C++. I don't know. C++ could be really slow or really fast. Same thing with web apps, right? Depends on how well you do it. Okay. Okay, now it's just a matter of parsing. I don't want to go overboard with the headers. I just want to pick out a few, because the class that does the parsing of headers we already wrote. We don't need to test it completely here. We'll just test that a few of the headers are there like we expect. We'll do the first, we'll do one in the middle, and we'll do one at the one at the end. How about that? So the last one's content type. And it's text plain. Yeah, if you want to check it out, Adam's game is bot.land. It's all written in React. React with a bunch of other things like Redux and about 50 other JavaScript libraries. Okay, the body's not empty. It's got to have this in it. And I already know we're going to have the same kind of checks on content length that we had in the server. Okay, so that's a good one to start with. Let's steal a bit from server. Server and client are going to be pretty close to each other. So we can take from server to fill in client. So we're going to need that structure, but we're going to turn it around. Instead of it being a request, it's a response. This represents an overall client response, or a response given to a client, really. Should I call it server response? I'll just be specific. I'll say it's an overall HTTP response given to a client, decomposed into its various elements. Response. We're going to replace the method with the reason, what is it again? Reason phrase. It's an odd name. This, I think, what my understanding is, this is the human readable text that describes the overall status of the request, right? It was either okay or it was not found. Question, do you do C++ for a job? Yeah. I've been doing C++ in that job for about 20 years. Didn't you ask me that like a while ago? Oh no, you asked me if I was new to it, but you didn't ask me if it's my job. Someone else must have asked me that earlier. Yeah, I work at a company where I've done C++ on embedded microcontrollers all the way up to Android phones. And a lot of Windows tools too. So I get to do things like mix C++ with Java and C# with toolkits like Swig. Very fun stuff. But on embedded targets, that's kind of where I got the taste for reinventing the wheel. Because when you're coding for a microcontroller, sometimes you're coding the OS and the drivers yourself, and it's not like you can download a library and get it to work right away. Okay, so the reason phrase, along with that, we got a code. So I'm just going to pick as unsigned int, status code. This is really the machine readable. The machine readable. This is the machine readable. This is a machine readable number that basically is the same thing, describes the status of the overall request. That's one of the cool things about HTTP. It's got information for both the machine and the human. And we had no target, but we have headers, which means we will need to include the header. Oh, why do I still have this junk here? We will not need OStream. I think we need vector. No, no vector. We need string. We don't need standard int, do we? But we need message headers. Oh, okay. Message headers. And body. Is that it? Is our test happier now? No, it still doesn't know what request is. We have to get to that. So server has parse request. We're going to have a parse response. Parse response. Raw response. So there's a clear parallel between requests and responses. This parses the given string as a raw HTTP response message. String parses correctly, equivalent response is returned. Otherwise, null pointer is returned. Raw response. The response equivalent. There we go. So let's give it a body. Actually, by this time, the test should start to be okay with the type at least. Oh, request needs to be replaced with response everywhere. So it's weird. I've been streaming for about a couple weeks now, and I didn't really expect this. But one thing I've learned is that the longer you stream, two things happen. Your voice starts to get tired, and more people start watching. I wish it was the other way around. Because by the time everyone's watching, my voice is all tired. Okay, so we don't have a URI target for response. But this should compile. It won't link, though. So by the way, for anyone who's just joining, I'm doing test-driven development. I'm writing the test first. It documents and tests the code that we haven't written yet. We write the test first. We get the code to compile with the test. The test fails. We fix the test by implementing the code. Should you know CMake when you learn C++ or even D? I don't know about D, but CMake is really just an alternative to writing or using Visual Studio, for example, and making project files and solution files, or using GNU Make, or even something closer to CMake might be AutoMake, an AutoConf. It's just one alternative for making a build system. I like CMake because with the single definitions, like something like that, This is all I need to describe my HTTP library for Visual Studio, for GNU Make, for Ninja, for Xcode. All of those build systems CMake can generate from this one definition, and the definition really is just telling CMake what I want to tell it. I want to tell it what are my headers, what are my source files, build a library, right? To me, it's basic instructions that I don't have to be encumbered with the special language of Visual Studio or Xcode or GNU Make or anything like that. So I like it for that reason. Am I talking too fast? I need to learn to slow down. That said, about CMake, if you're learning C++, don't do CMake. Learn one thing at a time. CMake in itself has a steep learning curve. I would just start with pick a build system like GNU Make or Visual Studio. Concentrate on learning C++. Then when you have the time to learn something else, learn CMake. Don't try to learn the two at the same time. I think you might get overloaded. That's what I would expect. Unless you're a super genius. Then learn everything at once. Go for it. Let's see. Okay, I needed to define that function. Or that method, really. Here it is. And again, I don't like to... I would normally have to do that, but here's a neat trick. Modern C++, so you can say auto and move the return value to the right. By the time it sees that, it'll know the scope is client, so I don't need to say client again. I love doing that. Now let's cheat again and take from parse request. We'll take this and we'll just kind of modify it to work with responses. So we just need to turn things around. Request becomes response. Raw request becomes raw response. We're not parsing the request line, we're parsing the status line. I think that's what they call it. Status line, yes. But it's the same kind of thing. It's going to be things delimited by single spaces. And it will be status line end. Bail if we don't find the end of the line. I'm going to go and search. This is going to be popping up a lot, so I'm going to do a search and replace for that. And same thing for request becomes response. 13 occurrences, okay. Okay, response line end becomes, oops. Oh, I messed that one up. Okay, that becomes status line end. Okay, that was only 2 occurrences. Raw request becomes raw response. We'll need a parse status line. We'll do that in a minute. But okay, after we need CRLF too. I'm just going to, for now, copy it. I'm already starting to think we're going to have some things in common between server and client that we'll want to consolidate together. But I'll leave that kind of consolidation for a later refactoring step. Oh, your Twitch app crashed? I'm sorry. Let's see. This is a character sequence corresponding to a character turn response. So it's the same as a request, so it kind of begs to be consolidated, but we'll do that later. But it's going to be the same thing. After a status line, there's going to be message headers, and there might be a content length. If there is, then we need to parse and read only up to that, and if it's not enough, we bail. All that stuff is basically the same. I think. Let's review. That was up. That were down. 333, right? The rules were a little bit different for a response than they are for a request. You're a little nervous getting to C++ because you feel like if you don't know the technical side of how to program works or whatnot, it'll be hard to learn. Well, what I'd suggest is pick something designed to be easy technically. So, and any of like the tutorials on how to learn C++, they'll give you something that's technically easy so that you can learn the language. Don't start by looking at something technically difficult in order to learn the language. Learn the language on something technically easy. Then once you know the language, you can get into something more technically difficult. Okay. Yeah, so rules 1 and 2 here. So rule 1 says that certain kinds of requests can't have a message body. And so again, a special case, a 200 to 299 response to a connect request, even if it has content length and transfer encoding, we ignore it. Oh, hi, Cyanox. Okay. These are really special cases. Transfer encoding is going to be common with requests, right? Yeah. So when we do transfer encoding, we'll have to handle it for both requests and responses. This 4 we're probably already handling. So the difference between request and response is when we're handling a request, we got this catch-all where there's no body present, but for if it's a response, we actually read to the end. So that's the difference. So that would be down here where the request body is read to the end. Raw response dot substring from the body offset on. And we're not gonna have this message end. What happens when you have a content length and what happens if there's a response with the content length and there's more octets? Sender closes the cache, recipient times out. Good question. What happens there? I don't see an answer. Let's look up content length in the context of a response. Okay, here we go. Okay. Okay, right. We might reuse the connection for additional requests. So we do have to have the same behavior where if it is present, so we're going to want that message end in there. Let's be a little bit proactive and put it back in there, and the server had an overload for that, so we'll put that in now. We'll just have to make sure we make tests to match it. So that's like this one. So the same kind of thing, only it also has a message end. So I'm going to take this comment, paste it there, and just extract the message end part and put it in here. The response message. Okay, good. And then we'll make that the body of what code we had been working on here. And same trick with the auto. And this becomes an overload of the other one, like basically what we did in the server. Only it's parse response, raw response. Like that. So we're just missing parse size and parse status messages. Parse size was in server. We'll just copy it for now. But again, strong candidate to be extracted back out into a common area. It begs to be extracted out, so we don't have two copies of it. But I'm going to hold off until we refactor. So I'm looking at the time. We're approaching midnight in 20 minutes, at least my Pacific time where I am. I think what I'm going to do, I'm going to plan to wrap up the stream within the next 20 minutes. So if you're just joining now, I apologize. I'm going to wrap up this client, or not wrap it up. I'm going to get the client class to about where the server class is and call it a night. And we'll continue tomorrow. So, you know, I mentioned I want to use this in building web apps. What's the benefit of using C++ for this as opposed to something like C#? Did it because it primarily work with C++? Well, one reason is C++ is easier to build for a lot of different platforms than C# is. Yeah, the compiler is readily available on Linux, Mac, and Windows, but for C# on Linux, I would need something like Mono, right? That's one reason I can think of. Another reason is, like what you're thinking, I primarily work with C++, so I'm more comfortable with it. That's probably the predominant reason. Okay, so I just need parse status line. I'm going to try to model it after parse request line. And we'll just mold it to fit the differences. This client. So that said about C#, there's probably lots of people out there who'd argue with me that, oh, you can run C# everywhere. I mean, Unity does it, right? Unity uses C#. Everything is sort of subject to conditions, context. Okay. Made that a free function, so there. So I'm gonna make it a free function here as well. This parses. So instead of method target URI and protocol identifier, it's gonna be protocol identifier, status code, and what is it called? Hold on, I saw chat, but I wanted to finish my thought here. Status line, right? What do they call it? Reason phrase. Still think that's an odd term, reason phrase, from the given response line, or status line as they call it. So you wrote this chat a minute ago, I'm reading it now. You see people using my library for things like microservices? Yeah, possibly. But again, I'm reinventing the wheel. This is sort of a weird thing to do. Most people would just take something that's already out there like Apache, or I still don't know how to say it right, nginx. Can't remember where I got that right. But you know, web server that's already out there. There's plenty of them. Nginx, yeah. You got it. So yeah, most people who aren't weird like me would probably just use one that's already written. I like to reinvent the wheel. I learn a lot about how things work by studying the standards and implementing it myself. Okay. So it's a client response that we're filling in. And this is a status line. I should make that prominent on my channel. Like, this guy is reinventing the wheel. Don't do this at home. Use something that's already out there and don't do it yourself. Okay, this is the response in which to store the parsed status code and reason phrase. I guess at some point I'll get away from reinventing the wheel when I get into the React stuff, because I have no interest in reinventing Babel or any of the other JavaScript libraries. Okay, status line. This is a raw status line to parse. Status line. Okay, instead of parsing the method, we're parsing the protocol. The protocol comes first in the status line. Would you intend to reinvent the encryption libraries? Actually, I've been talking about that in the previous streams. I'd like to, but I don't know enough about encryption. So I've researched for my job, actually, researched a couple different open source libraries that are out there. Like, you know, one of them is like really popular, OpenSSL. But there are a couple other ones that looked interesting too. I'll probably just pick one of those. My brother's a lot better at math than I am. He'd probably have fun reinventing the encryption libraries. Okay. This is protocol delimiter. And there, we're just going to move this up here. And again, we're only going to accept HTTP 1.1 right now. We'll have to loosen that up at some point. 0 to the protocol delimiter, no further. It's like, it's usually like one of those, leave it to professionals for me, yeah. Encryption's what we at work we would call, what would they call it? Work for systems folks. So deep niched domain knowledge. So if you studied encryption for years, you'd probably be apt to write the encryption library yourself. Otherwise, you just pick it up from open source or you buy it. Okay, so response. Okay, we're not storing it. No. We're parsing the protocol. We are parsing the status code next. And we're starting from the protocol delimiter +1. And hold on, there was the parse number stuff. We're going to reuse parse size. Why not? We'll reuse parse size. We'll just call it number. Well, status code is number. Might be overkill, but let's just do it anyway. So if not, parse size. And it takes what? The string and the number. So the string is status line substring from status code delimiter. No. It's protocol delimiter +1 to size code delimiter minus protocol delimiter -1. I know that's a mouthful. And put it in status code as number. If it doesn't parse, we bail. Well, thanks for coming by, JD. I hope it was interesting. Okay, yes. Oh, we're returning false if it's bad. Bye-bye. Okay, parse size. After we parse it, it has to fit into a 3-digit number, so we'll do a check for that. If status code as number is greater than 999, we return false. Rand? How did Rand get in there? Otherwise, we're going to typecast it and store it into the response. Status code equals unsigned int status code is number. Let's make that as size. There we go. Okay. Glad to hear it, by the way, JD. Good night again. So, status code is parsed. Last but not least, is we have to parse the reason phrase. Actually, we don't really need to do much other than get the rest of the line, right? So that's just response reason phrase is status line substring from status code delimiter +1. Return true. Okay, I kind of rushed through with that, but I think it's good. We'll let our unit test tell us if it was good or not. It was not good. Response code came out as 0. I had a feeling that would happen. When the later it gets, the more apt I am to rush through and screw things up. So, let us debug. Let the debugger be my crutch, and single stepping, it will see what I did wrong. Did it get the... Oh, I forgot to rename that. Should be status line. Anyway, it got the line correctly. And did it put... I called it request still. I forgot to rename that. Should be response. Okay, the status code... Okay, nothing got parsed correctly there, did it? Alright, well, let's fix some of the stuff up. Request should be response. Let's make sure it's not matching anything but that word. And then request line, same deal, becomes status line. Okay. This guy's got some problems, so let's go debug him. Status line, actually, okay, the status line looks good. Protocol delimiter, so the protocol is correct. Oh. I went too fast through that. It's not a tail call anymore. If it's not what we want, we gotta bail early. Otherwise, we gotta keep going. No, was that it? That wasn't it. So okay, we actually got much further, though. The body is just having a trailing end of line. Remember all those OpenSSL security issues? Yeah, I don't want to repeat that, do I? Well, that's a good point. If only one group of people is implementing the encryption and everyone else is using that, that's a single point of failure, right? So having someone else reinvent the wheel and make an alternate encryption library could be a good thing. I've never actually built OpenSSL, so I don't know. Is it like chock full of warnings? Like even from the compiler? I see that at work a lot. Like people don't really care about fixing the warnings they get from their tools. Valgrind being a little bit more aggressive than the compiler, I guess. Yeah, that's a dangerous thing to say. Hey, major banks are using that stuff, so they must be good. That's assuming, and you know what assuming means, right? It makes an ass out of you and me. Okay. Okay, let's single step through that because there's something else wrong. I tend to think that there's bugs in everything, and even something like OpenSSL probably still has bugs. It's the more heavily people depend upon it, the more likely we'll find those last few bugs that are in it. Okay, status code delimiter. This is probably where I screwed it up. Actually, it looks okay. Maybe I have off by 1 in this though. Number string. Oh no, that looks good. So we get 200 out, right? 200. Status code 200. Oh, right. That worked. I was forgetting. Everything is working down to the body. The problem is it's getting the extra new line at the end. let's look at the test, because the test might be incorrect. 51, let me count the characters. So that's on column 10. That's on column 59. So the difference is 49, 50, 51. Oh, so yeah, that actually is included. So it's a bug in my test. So we actually are passing now. At least the, what do you call that? The positive test case. Now we need to add some negative test cases. So a negative test case would be kind of like what we had in the server tests. We had incomplete body, right? Yeah, that's where we add more to the parse. We'll give it the same name. Why not? We basically bump up by any number, even just 1 is a good enough one. We don't do anything else because this is not going to parse correctly because it's truncated. Make sure that that works like we expect. Okay, good. Moving on, the next negative test case would be, yeah, so we chop it. We chop it before it gets to the body, so anywhere is good. That will be exactly like the server test. And then let's just, again, do what we did here. We chop it mid-request. That should also not parse. Incomplete request line. So here we'll even more aggressively chop it right there. And then here it's an incomplete status line. No headers request. Okay, so it's like that. Only it is a complete status line, there's just no headers at all. Okay, so here's where we get a little bit of a difference. If there's no content length and no chunk transfer encoding, it should, instead of, if for a request it would stop and assume there is no body, but for a response it's supposed to collect everything together, right? Because the rule in 3.3.3.6, I think, if the request message and none of the above is true, then the message body, oh no, sorry. Oh no, if that's for a request, right? If it's a response without a declared message body length, it's determined by the number of objects received prior to closing the connection. So it's basically all of what we get. So it's like this, but we remove the content length. Response. So we just remove the content length. We should get the same body back out. That's the only thing we really care about checking. Oh, and it parses correctly. I'm gonna have to wrap up the stream soon because it's almost midnight and my voice is starting to fail. Cool. Well, we passed a test. Let's see if there was anything else I'm missing. So I have the same kind of gambit of tests as I have for the server. Okay, Nolan, thanks for coming by. I'm wrapping up anyway, so you're not going to miss much. Have a good one. Okay, so let's just check that in because we're in a good state. Everything's passing. Client is caught up to server. Okay, we didn't have any code before, so really we're implementing implement client, implement basic response parsing. handle well-formed responses with or without content length supported, right? Not yet supported. Responses with chunked transfer encoding. I think it's transfer encoding, right? Yeah, transfer encoding. We're not supporting that yet. We need to get to that. Detect responses truncated in various ways. I think that succinctly describes what we did. And by the way, it's not the royal we. It's me plus you guys, the community, because I do get feedback. Can't remember exactly who it was, but someone told me a really great idea on how to test one of my components, and so I give you guys as much credit. So let's wrap that up. I just did a change almost unconsciously, right? That was just remove excess blank line. And make sure everything is checked in. So I'm going to use my Mugget tool. Ask it to scan each and every repository. I know I have an unchanged or an untracked file at root. I know about that one. Okay, everything else is clean, so it's probably a good point to wrap it up. Let me do a little overview, and I'll talk about what I'll work on tomorrow. Overview. So we started this stream at 9 p.m. Pacific. We finished up the Windows part of this library, which we're going to use a lot because it's got utilities in it. And let's see, I see some chat coming in. Oh, hi, Kamed. Web development with C++, is that a thing? Well, the keyword is reinventing the wheel. So it's a thing for me because I enjoy getting into the low-level protocols and implementing my own versions of things. So if that's interesting to you, you might enjoy the stream. If not, there's lots of other things to look at. I'm on stream 17, and I just got into the actual web server development, which I'm kind of excited about. So yeah, today I finished up all the prerequisites for running web server, and I actually started on it. So we have two classes now. We're developing server and client, and all that they do now is parse requests and responses into nice little structures. Probably tomorrow what we'll get into is registering resources and then dispatching or routing requests to them. So you're a CS student grinding web apps for summer internships. So you're probably way more knowledgeable than me at web apps. That's one thing I want to get into at some point in this stream, is transition from this low-level C++ into JavaScript web apps. I've toyed a little bit with React, and I'm looking forward to playing around with that more. Well, even so, I probably have only about a week's experience in it myself. So yeah, probably tomorrow we'll get into actual message routing with HTTP server. And I took some notes about what we need to handle. Some of the more esoteric things like chunked encoding, handling other protocol versions, handling compression. I'll add that to the to-do page. And yeah, that pretty much wraps it up. So another comment. Making JavaScript drive course for practice. Haven't gotten to backend or wrote many. Cool. Well, I don't know if game developers really need to know much C++ these days. Am I a CS student or grad? Not really. I'm more of a hobbyist who got hired at a big company and did well enough there that I've been working there for 20 years. I mostly taught myself, though, so I have a lot of bad habits to unlearn, which is one reason I'm streaming. I'm hoping people will point at my code and laugh at it, and then I'll stop and think, yeah, they're right. That I need to unlearn that bad habit and learn the right way to do it. Yeah, I was saying, like, as a game developer, I don't know if you really need to know C++. Like, for example, if you develop games in Unity, that's all C#, not C++. Oh, because of its performance? Yeah, well, what if you use a game engine to do all the low-level stuff for you? I guess it depends. It's almost a philosophical question. Is it okay to use a game engine, or is that sort of cheating, and should you do your own engine, right? Yeah, that's true. If you use a game engine when you're designing a game, you don't really know what you're doing under the hood. I didn't actually grok that correctly. If you use a game engine, you're designing the game, you don't really know what you're doing under the hood. Just, okay. I'm sorry, I'm having trouble grokking that. It's probably me because it's after midnight, and so my coach has turned into the pumpkin again, and my brain is shut down. Maybe Cyanox will back me up and. Yeah, C++ is what is described as a systems level language, so it's more for the elemental parts of something like a game engine. If you're reinventing the wheel, it's great. If you're trying to build off of other things, it's not really the best language, right? So it depends. Depends on the context. Yeah, there's always a stack, right? Even OpenGL is built on top of the primitive GPU instructions that it compiles to. Shaders, shader language, shader assembly, all that stuff. Okay. Yeah, so I'm going to wrap up the stream. Tomorrow we'll get more into this client and server class. And yeah, that's about it. So sorry if you're coming in a little late. I'm wrapping up tonight, but tomorrow hopefully start streaming 12 noon Pacific. So that's 12 hours from now. So I hope you guys all have a good night, and I will see you tomorrow. Is there anyone even online that I know that I could host right now? Let me check. Let me see. Nope, I don't know anyone who's streaming this late, so I'll have to just call it a night and see you guys tomorrow. Have a good one.